Alright, I am recording. Alright, so hope everybody's doing well today. Number of things to go over. Let me start off by mentioning that there's going to be a new entry code for getting into the Zoom meeting beginning tomorrow. So an announcement will go out right after this class that'll have a link to the new meeting code, and you'll have to use that to get into here. I sent email yesterday asking if anybody is registered for the afternoon section but attending the morning section. Please talk to me because we need to figure out some logistics of that. So the intent here is to split these two sections into totally separate sections. I'll keep the Canvas shells in sync, but the shells are already separated and we're going to have separate meeting codes for each one. So that begins tomorrow. Additionally, tomorrow I'm going to do as an open lab, so I'm not going to lecture tomorrow. It's going to be an open lab time where you can come in and certainly ask questions, but also if you want to work on your PA1 or other code, we can go into breakout rooms and we can screen share and you can show me what you're working on and so on. I probably will not do this in general on Fridays, but for the first assignment, since for a lot of us it's a first Java program, I want to have that opportunity to work one-on-one with you if you like. You can always find me in office hours, most mornings at 8, Wednesdays at 7, and you can try me Tuesday through Thursday at 11. Those are my lab hours. So I've got, several hours a week available there, but we'll also do tomorrow as an open lab. All right. That's administrative stuff. So, let me talk a little bit more about variable types. So we know that we can do something like, integer I equals 5. Integer j equals I times I, right? And then if we were to print out the value of j, right, we can do something like that. Right, and it does what we'd hope. I is 5, I squared, which is j is 25. And, I've said that classes always start with an uppercase letter and that everything is an object, but not everything is really an object in C. In Java, there are a few exceptions, such as ints, okay? These are things called primitives. Now, if I wanted to treat this as an object, I could do the following. I could say integer I equals new integer 5. And I could do integer j and do something like that. Let me make this a j. And this will also work if I get rid of the typos, right? But when I do this, when I'm doing this new here, I'm constructing a new object, okay? Object construction is kind of expensive. It takes time, it takes processing, it uses up a lot of memory, and integers are so commonly used that we would rather just do something like integer I equals 5, integer j equals I times I. So Java allows a few of these primitive types like int, okay? And they're a separate thing, they're not actually an object. But it lets us write code that, feels a lot like the way we write other languages such as C. And it's a lower cost internally to work with these primitives. So what are our options for primitives? Well, there's ints. Okay, that's just a plain old integer. And there's also short ints, which are just called short. And there's long ints, which are called long. So we have three primitives corresponding to integers. You've seen me use floats, and so there's a float and a double. Okay, single precision, double precision, floating point, 32, 64 bits correspondingly. So there's 5 of our primitives. We also have a character, and we also have a byte. A byte is 8 bits, okay? And it can be any 8 bits that we want. A character is any character, symbol, letter, digit, etc. And then there's also a Boolean. So those are our 8 primitives. And if we want a variable of any of these types, we declare it with the lowercase type, and it doesn't actually become a full bona fide object. It's just a primitive, and we can assign values to it and use it in expressions, print it, and so on and so forth. Okay, so that's one thing to keep in mind, and it lets us write code like this. So let's talk about Booleans. So I can declare a primitive like this, and set, Boolean done equal to false. And I can print it out, right? And it'll tell me done equals false. I could say done equals not done, so I'm negating with the exclamation mark. And now if I run this, it tells me done is true. I could say done equals parentheses 2 equals equals 1 plus 1. And it'll tell me done is equal to true. And if I say done equals 3 equals 1 plus 1, it tells me done is false. So this is kind of cool, right? Parentheses 3 equals equals 1 plus 1. Well, I'm comparing two things, two arithmetic expressions with an equal equal. The result of this comparison is a truth value. And an object, a primitive of type Boolean, can be assigned a truth value. So I can set done equal to true or false, or logical operations, or the results of comparisons. And I can also use these things inside if statements or while loops. Right, so now I can say if done, print out I'm done, otherwise print out I'm not done. Well, done is false right now, so this should print out I'm not done. Right, but if I negate that, now done should be true, so it should print out I'm done. Alright, so not terribly shocking there, right? But it is its own type of variable. And it's very different from C. In C, right, we basically used integers to represent Boolean values. So, Kernighan and Ritchie C doesn't have a Boolean type. It's represented with integers. And the understanding was if an integer is 0, it evaluates to false. If it's non-zero, it evaluates to true. We don't do that in Java. Okay. In fact, if I say something like, integer I equals 5, and I try to say if I'll get a compile error. And it'll say I'm using an int, and an int cannot be converted to a Boolean. Okay, which is not a bad thing. Now, if I really wanted to do something, if I was not 0, right, I would just say if I is not equal to 0. And that'll compile and it'll run fine. So Booleans are a separate thing, okay, and they act, exactly like you would kind of hope a Boolean was acting. And so we can use those inside loops, we can use them in if statements, and pretty much anywhere that we want a truth value to be plugged in. All right, so next thing I want to talk about is documentation. So let's go back to Canvas. And so on the 223 page, there's a link down here that says Java documentation, right? And if you click to that and click on through to get a bigger page, it'll take you to Oracle's online documentation for Java. So this is for Java version 8. It's a very stable version. It's not the latest and greatest, but it's you know exactly what you're getting with it. This is how the documentation is set up. And basically, there's packages. So packages are collections of classes that kind of belong together. So for example, there's a java.utility package, and it contains all of these classes, including the scanner class that we worked with the other day to do input and output. Okay, but if you're looking for documentation on string and you don't happen to know what package string belongs to, this doesn't really help you. So the easiest way to look up information on a class is, come to this page that you come to from Canvas, which is for all classes, and you just kind of scroll through here to look for the class you're interested in. So if we're looking for the string class, I'll scroll down to the S's and try to find ST. And this is painful for me, at least. So there's string, and you can click on it and bring up the documentation for strings. And you can also search with a Control F, and sometimes that works well, sometimes not. So here's the documentation for the string class. So I myself, I'm lazy, and I don't like doing things that I think are wasting my time. So when I want to find documentation on something, I have a doc command that just pulls it right up in Firefox, and that's just a bash script. Okay, I basically have a copy of the Java documentation downloaded, and I can just search through the names of the different topics for string. If you're interested in using that, let me know and I can try to get you a copy of it, but it's not really turnkey. It's not really something I can just give you and it'll work. It takes some fiddling with maybe to set up. Because I didn't make it for general use, I just made it for me. But you'll see me using this when we're talking about, integers. I'll just say doc integer, and it'll pop up a man page. But you can find it through the link in Canvas, right? You just have to scroll down to it. All right, so let's look at integers. Because int is a primitive, but there is an object of type integer that we can construct. So an integer, it comes from this package java.language, and an integer is actually a particular case of a number. Okay, a number is a more general thing, and it can be used to make bytes and doubles and integers and floats and longs. Okay, and integers come with, a few methods and a few ways to one way to construct them, right? But we're interested in integers. So this is class extension. When we made a myFrame to look at GUIs, myFrame was an extension of JFrame. Well, an integer is an extension of a number, and a number is an extension of an object, right? In fact, everything is an extension of an object. And objects come with a few methods, such as clone and equals and toString. So if I don't define a toString inside a rectangle will be an extension of an object, and objects have toStrings. Okay, so that's a topic we're going to talk about in detail a few weeks down the road, but I just mentioned it in here. So let's look at integers. Integers can be constructed by passing a number to them, an int. You can also construct an integer by passing a string. So over here, if I had said something like right? So I'm going to set I equal to new integer double quote 5, and I'm going to set j equal to I times I. This should tell me that j is equal to 25, which, not surprisingly, it does. So we can construct an integer with a string, or we can construct it with an integer. And then there's various methods available. We can turn an integer into a byte by saying byte value. We can compare an integer to another with compare to, while we can also use an equal sign, right? But as an object, it has a method called compare to that we can feed another integer, uppercase I, and it'll give us an integer back that tells us which one is bigger than the other, and so on and so forth. All right. It's worth mentioning at this point that this documentation that looks this particular way, it has the name of the class up at the top, it has what this thing is derived from, a few sentences describing the class, a list of the fields. So there's a field called max value that tells us the largest value of an integer. There's a size that tells us how many bits are used to represent an integer, and so on and so forth. Ways to construct it, and then a summary of the methods. And the methods, you know, you can click on and it'll take you to more detailed information. This is a very standardized presentation of information about a class in Java. Okay, and it's standardized in the following way. When you write Java code, you can make a comment, right, by putting in 2 slashes. You can make a block comment by putting in a /* and eventually ending it with a //. Okay, but if you make a comment that starts with a /**, well, that's really just a block comment, right? This asterisk is just part of the comment. It's technically ignored by the Java language. But there is a tool called javadoc. And if you run javadoc on your Java source code, and you have comments written like this, it will interpret the comment as containing information about your class. And based on that interpretation, the javadoc command will actually build you a web page that looks like this. And it's a really easy, really powerful way to create standardized documentation about your classes. And all it takes is adding a few lines to your code as you're writing it. So how does this work? Well, when you're making a class, if I put a block of comments in the beginning of the class like this, I can include things like the description of the class, the author, and so on and so forth. If I put a block of comments like this right before I define a function, I can put in descriptions of what the arguments are, what type of thing they are, what their values mean, what the return value is, what the function does, what errors might come from it, and so on. And javadoc will interpret all of that and generate this nice standardized output, which says, you know, what the parameters are, what the return value is, and so on and so forth. So we'll play with javadoc later on, and when we get to using Eclipse as an IDE for writing this, it makes it really easy to do Java documentation, because if I just say /** in the front of a method, it will create a template that I just fill in, you know, what does this argument mean, what does that argument mean, and so on. So this is part of why I want to stress documentation and commenting in your first programming assignments, because we can take advantage of things like this javadoc tool to do really nice documentation of our work. And I've actually used this on my own, right? Not for a class, not that I was being graded for it, but I was making you know, Java classes, and I knew I was going to keep them around for a while. Some of them I've had for 15 years now, and you know, you can document them like this. So that's pretty worthwhile. All right, and if questions or comments come up, you know, just shout them out. Okay, so this new keyword, if we're dealing with objects, not primitives, we've done something like, let's make a rectangle R and set that equal to a new rectangle 10, 15. Okay, when we do the new keyword, the Java virtual machine will go into this class and it will look for a constructor that takes 2 arguments that can be gotten from 10 and 15, so integers typically. And if it finds it, it will execute that code. It will allocate memory inside the virtual machine, okay, kind of what we do with malloc in C. It will allocate memory in the virtual machine and then do whatever initialization is done by this constructor. And the result will be, somewhere in memory, there's this rectangle with a height of 10 and a width of 15 and maybe some other stuff. And that's the return from this new keyword, and now we set R equal to that, so R is a reference to this object. Okay, this is an object of type rect, and R is a reference to it. Now later on, if I do something like this, R equals new rectangle 5, 7, well, same thing happens. New says, okay, let's go ahead and allocate memory for this rectangle object, and the constructor will say set the height equal to 5 and the width equal to 7 and some other stuff, and then it'll say let's set R equal to that. Well, since R is pointing to this object in memory, it's no longer pointing to this original object in memory. There's no way to get a hold of this object anymore. Right? The only reference we had to it was this object R, and R has been changed to point to this new object. This object is lost. Okay, in C, that's a memory leak. We can never free that memory, and when our program exits, malloc would, or Valgrind would say, you lost some memory here. Okay, in Java, we don't have memory leaks. We have garbage. And this is considered garbage once nothing is pointing to it. And there's a piece of the Java virtual machine called a garbage collector. And periodically this garbage collector fires up and it looks for stray pieces of memory, stray objects that aren't being referred to by anything. And it says, well, this is doing nothing but taking up space, and it will destroy this object and reclaim the memory for the Java virtual machine. And it's smart about how it does this. If I have a rectangle R2 and I set that equal to R so that R2 is pointing to this. Now when I change R to point to this new rectangle, R2 is still referring to the old one. The garbage collector will not collect this object because it'll say, oh, something is still referring to it, right? And if this got freed from memory and then I tried to look at R2.height, I might get garbage. But if I do something like R2 equals something else, and I take away this reference, this is now not being referred to by anything, the garbage collector will gather it up and reclaim the memory. So we really can't get memory leaks. We can't get memory leaks that we have to worry about in Java, right? If we abandon an object, we leave it to the garbage collector to reclaim that memory. So it lets you be kind of sloppy and carefree in writing your code. When you're done with an object, just don't use it anymore, and have faith that the garbage collector will handle it. Now, if we created a really large object that takes a huge amount of memory because we wanted to do something, and now we don't want to do that thing anymore, we can ask the garbage collector to run, and it'll go through and it'll pick that up for us. But generally, it does a good job on its own of gathering things up. And our typical machines have, I don't know, 8, 16, 32 gigabytes of main memory now, so this isn't really a big issue, but it's a nice convenience. So we don't have to do mallocs, we don't have to do freeze, okay? And we don't talk about pointers. We rarely talk about pointers. So this may be making you happier than C already. Alright, I'm going to to talk about something slightly confusing. Let's go back to our rectangles. So rectangle R equals new rectangle. And if I want to find the area of R, remember we just said R dot area. And it would run this method on, you know, that object. And inside this object R, there was a height and a width, and the area method said multiply the height by the width and return that. Okay. This is technically something that we call an instance method. Okay, instance method is just terminology for saying this is a method that we run associated with an instance of an object, right? An instance of a class. Rectangle is a class. R is an object. It's an instance of that class. So R dot area, right? Same thing if we have a string. If we say string s equals blah blah blah, we can say s dot length. And it'll run this method on that object, right? And it'll give us the length of that string. Okay, suppose you want to find the square root of a number. Suppose we want the square root of 2. So let's write some code. So I'll set x equal to 2, and I'll set y equal to the square root of x. And I'll print the square root. Okay, if I try to compile that, it will say there's no method named square root. Okay, why? Because it's looking for a method inside here, and I haven't written a square root method. So where am I going to find square root from? We can import classes, right? But we don't really have a way to import functions per se. I can't say include math.h, right? And that'll give me a square root. So where are we going to find the square root from? Well, it's part of a class. Okay, there's a class called math, and if you look at the documentation for math and we look at the methods for it, there's a method called square root. And it takes an argument and it returns a double, which is the positive rounded square root of the argument. All right. Let's think about this. So square root is part of the class math, and I want to say something like, you know, y equals square root of x. Well, square root is part of math, right? If I had a math object, I might be able to say, you know, math object dot square root. But I don't really want a math object, right? I just want the square root function. So there's a special kind of method that we can make in a class. And this is something called a static method or a class method. And when you look at the documentation, you'll see that square root takes a double, returns a double, but it's defined to be a static method. Okay, what does this mean? If you have a static method, you do not need an instance of the class to run that method. Okay, area, we need to have a rectangle to say rectangle.area. A string, we need to have a string to say string.length. But square root, we don't need a math object to take a square root. We can actually just type the name of the class dot square root. Okay, so this is an example of a class or a static method. Okay, so every time that we've talked about methods so far, it's always been an object dot a method. with a static or a class method, it's actually the name of a class dot a method. And this works precisely in those cases where we're told that the method is a static. So if we want to find the cube root of a number, we could say uppercase math dot cbrt, and that gives us the cube root. Alright, so what does this look like in code? Y equals math dot square root of x. So that compiles, and if we run it, there's a square root of 2. Okay, so that's a static method or a class method. And the math library is particularly useful, right? It has lots of methods available to us, so we can do, absolute values. We can do trigonometry, forward and inverse trig functions. We can do ceilings and floors. We can do exponents. We can raise Euler's number to a power, right? Exponents. We can do logarithms and so on and so forth. And almost every method in here is static. There's also static fields. So there's a field called E and there's a field called pi. And it's a static. So for example, I could say something like pi equals, and I can concatenate to that math.pi. It's not a function, it's not a method, it's just a field. It's like, rectangle dot height, right? It's part of the math class, but since it's static, I don't need a math object. I don't need a particular rectangle. I can just say class name math.pi, and I can access that. So if I run that, it tells me the value of pi. Alright, so that's the deal with statics. I'm going to ask you not to write statics except for public static void main. Okay, but eventually we'll see how to use statics in a reasonable way. When I first learned Java, I started trying to make everything static, and it worked for a little while, and then it totally blew up in my face, right? You can get really, really far down a rabbit hole making everything static, and eventually you suddenly realize that it's not working anymore, and you have to undo everything that you made static except for public static void main. So if you start getting messages about, expecting static or not expecting static, don't just change things until it works, okay? Hopefully at that point we've already talked about this, but if not, right, shoot me a note and I'll talk you through the specifics. But they have very specific meaning, what it means to be static or not static. All right, let's dig further into some details. So let's talk about args. We always put the string bracket args in here when we write a main function. A main method. So main is the name of this function, this method, right? And it's a magic word. Right, so if we do this, it prints out hello. If I call this, something different like haha, I can still compile, but when I try to execute, it'll say there's no main, right? So this has got to be called main, and it's got to be string bracket args. Right? If I make it a main that doesn't have, string bracket args, I can compile, but I can't execute, right? Remember, there's a signature associated with methods. the method is defined not just by the name, but also by the number and type of arguments. So it's got to see string bracket bracket args in order to execute as a main program. Alright, so what is this business with args? Well, as you might guess from the bracket bracket, it's an array. And what is an array of? It's an array of strings. Okay, so we could do the following. Let's print out the value of args bracket 0. Since it's an array of strings, well, if I say Java main, I get an exception. It says array index out of bounds. Index 0 does not exist. Why? Because I didn't put any arguments on here. But if I say Java main, this is a test, it tells me args bracket 0 is equal to this. That's the first argument that I put in after I said Java main. So args is an array that corresponds to each word, you know, or space separated string that I put after Java main. This is exactly argv from C, right? Args bracket 0 is like argv bracket 0, except we don't get argv 0 being the name of the program. It's actually just the first argument that we specified. So I could put a few more of these in here. Like this. And now if I run this, arg0 is this, arg1 is, arg2 is And the usual things, you know, if I put some of these inside quotes, you know, my third argument, single quotes. Right, my third argument is a bunch of spaces test. Right, but if I put a bunch of spaces in between this and is, they're just separators, right? My first argument is this, my second argument is. All right, so we can use this to pull the arguments off. The other question is, how many arguments do we have? Where's our version of argc, the thing that tells us how many arguments there are? Well, it turns out when you have an array, any array, it turns out if we have an array, we can say args.length, and that will tell us how many things are in the array. Okay, and this is not a function call. Okay, this is not, you know, like length parentheses parentheses, which was a function we were running as part of an object. This is a built-in thing. When you have an array, that array has a field that tells you how many things are in the array. So we could say number of args equals, and we could print out the number of args. So if I say Java main, this is a test, it tells me number of args is 4. So now we can do something a little more nuanced. So we can print out all of our arguments and only all of our arguments using a for loop. So I'll iterate I from 0 to number of arguments minus 1, and I'll just print out args bracket, you know, I equals, and I'll show the value of that argument. So we've seen this code before. So here it is again in Java. Number of arguments is 4, and the arguments are this is and test. If I run this with no arguments, it tells me number of arguments is 0. So this is pretty straightforward, right? It's a single thing that we put into our description of main, which is just an array of strings. every array has a built-in length that we can get to by arrayname.length, and then we can access the nth element with just array name bracket n. All right, while we're in here, there's also a printf function available. So I could do this. If you miss C already and you want your printf statements back, there's a built-in printf. So you can say printf args bracket %d equals %s, and it should go ahead and do the same thing, right? So it's a little more convenient sometimes to just concatenate things together like this, but you know, if you want precision, we can do it with good old printf style, and we can do things like, you know, let's print out a 2-digit number with leading zeros included, and let's throw some delimiters around here. And so you can do more precise formatting and so on. So printfs are available. So let's wrap up with just a simple function. Let's find the product of the arguments. Let's make a program that you can say Java main 234, and it'll tell us what 2 times 3 times 4 is. Okay, so let me clean up some of this stuff. Let me start a new program. So we'll do a running product. We'll start off at 1, and then for I equals 0 to the number of args, product equals product times args bracket I. And then let's just print the product at the end. So this will not work. Right, when I try to compile it. Interesting. That's weird. Oh. This will not compile. Okay. Because, well, aside from this typo, let's put this back to args.length. Aside from that, it's going to complain that I'm trying to multiply an integer by a string. Okay, so first type is an int, second type is a string. The star operand is not supported for that. So you can't multiply integers by strings. And these args are strings, right? Even if it's just a string containing the number 2, it's still a string. So we need to convert from strings to integers. Right, just like we did in C. Now in C we did this using scanf typically. In Java there's a variety of ways to do this, but here's an easy way. If we look at the integer class, there's a static method called parseInt. ParseInt will take a string and return an integer. So I can parse this as follows. I can do integer.parseInt args bracket I. This will take this string, turn it into an integer, and then multiply that by the product. So this will give me my running product. And if I do 2 times 3 times 4, make it main 7. If I do Java main 7, 2 times 3 times 4 gives me 24. Right, if I do 2 times 2 times 2 times 2 times 2, I get 32. Right, so this is an example of a static method in the integer class. Very straightforward, converting a string into an integer. Of course, if I do 2 times 2 times haha, I get an exception. Number format exception for input string haha at line 7 or line 8 of main7.java, and other lines inside the internal code of an integer, but basically it can't convert haha to an integer. All right. Last thing I'll just mention, if we look at parseInt, there's another version of parseInt that takes 2 arguments, a string and a radix, right? And the radix lets us specify the base of this number. So if I wanted to do hexadecimal multiplication, like 15 times 15, right, I get my error because f is not a decimal number. But by simply changing this integer.parseInt and saying comma 16 to say this is going to convert a hexadecimal number, right? Suddenly I'm running with hex, right? I'm doing f times f, that's 15 times 15, that's 225. And if I do 10 times 10, that's actually 16 times 16, which is 256. So get comfortable with the documentation. That's the punchline here, right? Follow the Canvas link to your documentation and get comfortable with just kind of like browsing through this stuff, right? Finding where things are, and when you have some downtime, right, look at some of these classes like integer and character and math and see what sorts of things are out there. There's a lot of capability, and part of the whole idea of object-oriented design is you create these objects that are coming from classes that have lots of capability built in, right? The integer class has presumably a lot of things that you might want to do with integers. It's already built in for you. Take advantage of that. Strings too, right? There's very little string processing you have to do by hand. Most of the stuff you need to do, there's methods inside the string class for. All right, so tomorrow's class is an open lab. Tomorrow's class has a new link you have to follow for the afternoon section, okay? So there's an announcement going out on Canvas in about 10 minutes that will list the Zoom link that you need to get into class from this point forward, okay? So open lab tomorrow. Come in if you want to ask questions, work on your code, run things by me, and so on, okay? Otherwise, just have a great day, and I will see you next time.